Hello, ladies and gentlemen. Welcome back to my channel. This is Mr. Arias, and in today's video, we're going to explain how to convert the quadratic function into factor form. Now, just so you know, the context of these problems are going to be questions in which you have a quadratic function initially that is in standard form. And just so you know, here's the quick visual representation of the process that we're going to apply in today's class. So imagine that you have a function in standard form that has the following equation. F of x is equal to ax to the power of 2 plus bx plus c. And then our objective is to turn it into a function that looks now like this. F of x is equal to a times x minus p times x minus q, where the values of p and q are just going to be any numbers, decimals, or fractions that we could potentially come across during this process. And basically, just so you know, the main step that we're going to be performing right now for this transformation to take place is going to be the process called factoring. Okay, it's going to be factoring. So what's going to happen is that we're going to use factoring. We're going to factor this trinomial, which appears in the function in standard form, and then we're going to just break it up into factors that look like this. Two binomials multiplying each other, and then a constant a multiplying those two other parentheses or binomials. Okay, so that's pretty much what's going to happen. Let's go over the process. We have pretty much 4 steps. Step 1 is to use the box/area method. If you do not know what I'm talking about, I invite you to watch this video, this other video that I have in my channel on how to use the box method, also known as the area method, in order to factor or multiply any expressions. So when that happens, feel free to come back to the video, and then you're going to see how we're going to make use of this process and this method. The second step is going to be to find the factors of the quadratic term, which in this case would be our ax to the power of 2. The next step, step 3, will be to find the factors of the constant term, which is the positive c in your function. And then lastly, we have to check our work. And I'm going to show you exactly what I mean by that, which is the most important step of this process. Okay. Now let's get into an example. The example that I have for today's class is the following. We have a function that is quadratic in standard form, and the equation is the following. F of x is equal to 3x to the power of 2 plus 12x plus 9. So I'm going to be applying, like I said, the box method. And what that means is the following. I'm going to draw my box, which is just a rectangle, right? And since we have a trinomial, that means that my box is going to have 4 entries. So if you watch the video about the use of the box method, you're going to realize that these 2 terms, the quadratic term 3x to the power of 2 and the positive 9, have some designated spaces inside the box. So 3x to the power of 2, or the quadratic term, is always located in the top left position of my box. And then my positive 9 is always across that term in a diagonal direction, which means that its location is going to be in the bottom right section inside the box. Okay, so keep in mind, outside of this box, we're going to have 2 factors or 2 binomials that if you multiply them, they produce the terms inside your box. So also another comment is that these empty spaces are going to eventually turn out to become like terms. And that means that we can add them or subtract them depending on the situation of the problem and depending on whether they're positive or negative. Okay, so I'm going to just quickly go back to step 1. Step 1 is to use the area method. We have it. This is pretty much the setup of the problem. So the second step is to find the factors of the quadratic term. So what that means, ladies and gentlemen, is that we are going to fill out these 2 spaces along the base and the height of my box in such a way that those turn out to be factors of 3x to the power of 2. Now, if you think about it, can you think of any potential terms that when I multiply them, they would provide this answer, 3x to the power of 2? Okay, so after playing with the factors and maybe testing a few options and combinations, the one that I recommend in this case is multiplying 3x times 1x. Because if you multiply 3x times 1x in the following fashion, base times height, we get 3x to the power of 2 in the top left entry inside the box. Now, after this, I'm going to just separate these terms with pluses, and then the next step is going to be to find the factors of the constant term, which in this case is my 9. So for the 9, again, you can play with the combinations. You can multiply 1 times 9, 9 times 1, same thing, or 3 times 3. But in this case, I'm going to go with pretty much, let's see, which one should I go with? I'm going to go with 9, 9 times 1. Okay, just to show you that that's another combination that you can use. Some people think that this combination doesn't work just because 1 is a simple number, but just keep in mind that any two factors of a number are basically factors that when you multiply them with each other, they will produce the answer that you're looking for. So 9 times 1 is a valid answer or option or combination in these examples. Okay, so now if you check 9 times 1 is equal to 9, so this makes sense. That provides the bottom right entry in my box. So we have step 1, step 2, step 3, and then just so you know, we have these empty spaces. However, now we're going to be able to find some values in those spaces because you can multiply the 9 that we placed along the base of this rectangle or this box times the 1x that is located along the height. And that would provide this term in the top right section. So what's going to happen is that you're going to end up multiplying 1x times 9, and that will give you 9x in the top right entry of this box. In the same way, to get this bottom left entry inside the box, you would have to multiply the 3x from the base by the 1 from the height. So what that means is that I would multiply 3x times 1, and that would give me this answer that is supposed to be located in this entry down here. Okay, so step 1, step 2, step 3. Lastly, ladies and gentlemen, check your work. So this is really important, and what this means is the following. So if I take all the terms out of my not the binomial, out of that box, so all these 4 entries inside my box, if I take them out and I combine any like terms and simplify, if we get back the same expression for the function that we have in the problem, that means that we did the factorization properly and everything is good. But if those terms do not eventually combine, add up, or subtract to this original function, that means that something happened along the way, and we have to recheck the process of factoring by using the box method again. So in this case, I'm just going to take all my terms outside in the following way. So I'm going to take my 3x to the power of 2 and my positive 9 outside. And then we're going to just take the 3x and the 9x also, and I'm going to place them right here. And if you notice, what's going to happen is that 9x and 3x are like terms. So I can add them up, right? And they turn into 12x. And then if I just drag down my other terms, 3x to the power of 2, and then my 9, we actually get back the same function, which we had initially in the problem. 3x to the power of 2 plus 12x plus 9. Now, what this means is that the factorization was done properly. However, this is not the answer. The answer, ladies and gentlemen, is the binomials that you found across the base and the height for this factorization using the box method. So basically, what this means is that now your function becomes the following. You have parentheses 3x plus 9 from the base times x or 1x plus 1 from the height. And that's technically the new function that we have in our hands right now. And if you think about it, it looks pretty much like the equation of the function in factor form. Okay. Now, I kind of wish that I could say we're done 100% with this problem. We're actually not at this moment. And that's because of the following. So keep in mind that in order to say that you're done with this problem and this factorization, 3 things have to happen. Number 1, you have to have a value of p. Number 2, you have to have a value of q. I have a value of p, which is positive 9, and then I have a value of q, which is positive 1. Don't pay too much attention to the pluses and the minuses right now. Eventually, we're going to explain why it's okay to have a plus or a minus inside the parentheses or the binomial. But the problem is this. We do not have a value of a, right? So that seems to be empty right here. And that would be a problem. We have to be able to find this value, the value of a that completes this equation of the quadratic function in factor form. So what's going to happen is if we had, let's say, any value of a that was just equal to 1. Let's say we have just 1x to the power of 2. If you had a function like this, and you're doing the factoring process using the box method, you would be pretty much done by now, after performing step 1, 2, 3, and 4. However, if your value of a, ladies and gentlemen, is something higher than 1, there's a high chance that you're going to have to apply this extra step. Now, the extra step is basically step 5, which doesn't apply to all the functions, only potentially to functions whose value of a in that quadratic term is going to be higher than 1. And that is, we have to get the GCF out of your parentheses. Now, what the GCF is this value, the highest number that you can divide any two numbers or three numbers or four numbers in an expression by in a clean way, which means we do not get any decimals back. It's just this nice division that we can perform using that value or that GCF. So what this means is for the extra step, I'm going to have you just look at the parentheses and see if you have any GCF between those two terms in each parenthesis individually. So for example, if you check the second parenthesis, we have 1x or x plus 1. And in this case, the highest number that I can divide those terms by in the second parenthesis would be just 1, right? But that's nothing special. Nothing really happens. It's like if I get the same parentheses back after dividing by 1. So the second parenthesis is nothing to be concerned about. It's pretty much good. It's not going to change. However, the first parenthesis, though, is one of our interest because we do have a greatest common factor that we can pull out of those two terms in my first parenthesis. And what that is if you check it out, a positive 3. Because I can divide 3x and 9 from the first parentheses by 3, which is the highest number that I can use and get a clean answer for each one of these terms. So what this means is now that my parentheses, if I divide by 3, is going to become the following. We get parentheses, just x, and then for the second term, we get 3. Like I said, nothing happens to the second parentheses. But now what I'm going to do here is I'm going to take my GCF, which is 3, and I'm going to place it on the left-hand side of the parentheses. That way, I can use it as the value of a that I was missing initially in my factorization. So what this means is that now we have something that looks exactly like the equation of a quadratic function in factor form. I have a value of a, which is 3. I have a value of p, which is 3. And I have a value of q, which is positive 1. And now at this point, ladies and gentlemen, you're officially done with this factorization problem. And you turn this function from standard form to factor form. That's it. Okay. Thank you for watching the video. Have a wonderful day, ladies and gentlemen, and I'll talk to you next class. Bye-bye.